Okay, so yesterday we started one of the last chapter for our course, that is dynamic programming. Uh, we studied about what exactly is dynamic programming and how basically is being used, and what how to identify basically what is a dynamic programming problem. Identifying uh, the DP problem. Okay, this is what we discussed. We discussed about different kind of properties that any DP problem will have. We discussed about what do we mean by overlapping subproblems. We discussed about optimal substructures as well. Overlapping subproblems. We discussed about optimal substructures as well. We took the examples of factorial of a number and Fibonacci series so as to identify the difference between tabularization and memoization. We discussed about top-down approach and bottom-up approach. So this is what kind of the theory that we discussed yesterday in regard to dynamic programming. Apart from that, we started with a new problem. We started with we took one example of a rod problem, cutting rod problem. Cutting rod problem. The problem statement was given a rod of length, of length, let's say n inches or something. We were also given an array of prices where if we sell the rod at different components, we are going to get the respective profit to them. We wanted to basically sell the rod by selling any number of pieces with different lengths, so as to earn the maximum profit. For example, the input was, let's say yesterday, what was the input? The rod was of length 8 inches, and this was the price array that was given to us. P1, 2, 3, 4, 5, 6, 7, 8. What was this array?
1, 5, 8, 9, 10, 17, 17, 20.
Yeah. So basically, this array was basically telling us that if I sell 8 inches of rod, I'll get 20 rupees. If I break the rod into multiple components, that the respective profit that I can get is with respect to this. This is prices. For example, if I make a cut at 4 inches, I will be getting two components of 4 inches and 4 inches, and then the profit that I'll make is 18 rupees for 4 plus 4. Now this 4 I can further divide maybe into four pieces of 1 each, or maybe 2 pieces of 2 each, or 1 piece of 3 and 1 piece of 1, or something like that, any configuration, and I'll add up the respective profits. For example, in this case, it will come to be 4, it will come to be 10, this comes to be 9, and similarly for this 4 as well, any configuration. So that was the complete thing. Basically my objective is to earn as maximum profit as I can by making any number of cuts I'm allowed to, but I should be able to earn maximum profit. So in this case, the output that we expected in our thing is, I guess, 22, because if we make a cut at 2, we get 5 and 6, I mean to say 5 and 17. So if we make a cut at 2, we get 2 blocks of 2 and 6 each, and the profit is 22. I think that is the highest profit as well. You can try to find any other combination as well, but that is what we kind of achieved yesterday. That 22 is the best profit that I can earn by making a cut at 2 inches, and I'll be getting 2 pieces of 2 inches and 6 inches respectively, and selling them at 5 and 17 respectively. That's it. This is what we discussed. Why this is a dynamic programming problem? Because there are sub problems that are related to each other. Making a cut at 2 will give me another sub problem of, basically now I have 2 rods of 2 inches and 6 inches. I again have to optimize them. and optimal sub problems, because optimal substructure, because if I won't be able to optimize my two pieces of 2 and 6 respectively, I cannot have final 8 inches piece optimal with optimal profit, right? So this is what we have. We finally discussed, I think we wrote the recursive function as well over here, that got rubbed. Okay, let me write it down again. We achieved at a solution where we write down the solution, the recursive function. The recursive function that we wrote for yesterday was something like that: cut rod of n will be equal to, yeah, that's the program, right? Yeah, I'm writing the recursive function. Cut rod of n will be equal to maximum of price of I plus cut rod of n minus I for all I equal to 1 till n, and equal to 0 if n equal to 0, right? This is what the recursive function we kind of concluded yesterday only. So far I haven't come to the today's agenda. It is all that is being discussed yesterday, right? We wrote a program as well, which is being written just on the board, where we have int cut rod of n if n equal to 0, return 0, else for int I equal to 1, I less than I plus plus max price of I plus cut rod of n minus I. You can see from the code as well, it's pretty much simple, just implementing this in kind of programming language, just four lines of code. Further, we have already drawn on the board that if we do this kind of a function, let's say for the cut rod of 4, the recursive call that I'll be making will be equal to maximum of price of I, which means to say price of 4, which is price of I will start from 1. So it will be maximum of 1 plus 1 plus cut rod of 3, comma 5 plus, there will be another call, 5 plus cut rod of 2, and further will be 8 plus cut rod of 1, and further it will be 9 plus cut rod of 0, right? And cut rod, this will be further, will be evaluating to 1 plus cut rod of 2, then 5 plus cut rod of 1, and further 8 plus cut rod of 0, right? And so on for the cut rod of 2 and 4 cut rod of 1, and so on and so on. This will further, and this is just for the cut rod of 4. We are actually passing cut rod of 8 to our use case. This is just one of the calls that I'll be making when I'll be doing cut rod of 8, right? Now if we analyze this recursion tree, we can see that cut rod of 0 or cut rod of 1 or cut rod of 2 has been called so many times. Again and again, I should be able to reuse the output that I have got once I have computed them. For example, if probably this call will be coming in the very last, right? Because cut rod of this thing then, and cut rod, and this call, the cut rod of 0 will be called somewhere down the line here as well. So when I computed cut rod of 0, I should be directly be able to give me the result of cut rod 0 by reading from some table or by reading from some array or from some memory, whatever it is. But I should not make a recursive call again. That is what the next part is that we wanted to highlight and solve today, right? So understood what we are trying to solve today, what we had it yesterday, what was the problem statement, what was the recursive function, and so on and so on. We'll come to the complexity in other parts later, but let's try to solve it first. Okay, so let's try to figure it out, whether how I can basically solve my this thing, how I can get my how I can store the calls, and how I can pre-process the results, and how I can avoid any kind of redundant calls in this complete problem. Okay, so that's it.
This sort of problem, every time there has to be explore all the combinations.
Yes,
there is no other way.
There is no other way. That is why these problems are very, very difficult to handle, because there is no straightforward way. You have to explore all the possibilities. Right? So that is why they are difficult to think about. They are kind of difficult to visualize. They are not a straightforward approach. Yeah. So that's it. Let's go further. Uh, okay. So let's have the same array and tried yesterday, right? Did no? Yes. Okay. Let me redraw the array again. Yeah, sorry, I want the array input again so that it can help us.
One, five, eight.
Just a second. Just a second. 1, 2, 3, 4, 5, 6, 7, 8. 1, 5, 8.
9, 10, 17, 17.
Okay. Yeah. So let's see what is the new program that you have told me. We'll quickly write the program. We'll go through it. We'll see whether that is the correct solution or not. If that is well and great. Otherwise, I'll try to help you out. Okay. Okay. So let me write int cut rod of n and something like that. And you want me to create a global array?
Yes.
Right. Okay. Int arr of 8
Size n.
size n. Okay.
What
In our
size you pass initially.
yeah, let's say okay. Is it fine? Okay.
It will
Now,
all initialize to minus 1.
yeah. By default, they will be initialized to minus 1. Okay.
And then first, like earlier, if n equals to 0, return 0.
Okay. Let me write it down that thing as well. If n equal to 0, return 0.
If array of n not equal to minus 1,
Return arr of n, right?
return it.
Okay.
Then else part, same for int max.
Int max. Do I need to take int max? Do I need to take int max? Okay. I'll leave the space over here. If required, we'll take it. Okay.
For int I equal to 1, I less than n, I plus.
I less than n, I plus less than or equal to, right? I plus plus
Max of
max of price of I plus cut rod of n minus I. Okay. This thing should be come to.
This should be returned as array of
Arr of n.
error of n.
Okay. Just a second. Let me see. Return arr of n. Okay. So just go through it, guys. Is there any problem with this?
Should be higher.
Arr of I, huh? Okay. Okay. Cool or not? Okay. Whether it should be I or n? N. Okay. Let's try to see. Okay. Let's try to give a dry run for this program. Okay. So cut rod of 8 is called here. Okay. Cut rod of 8 is called initially, and let me create an array of for my this thing. This is my ARR, guys. Okay. Which is initialized to -1. Everything is -1 initially, and cut rod of 0, anything in this thing. So cut rod of 8, and if n equal to 0, no, it is not. If ARR of n equal to -1, yes, it is -1. Go further. So basically, the call will be for I equal to 1 till 8. I equal to 1 till 8. Do something. Okay. ARR of
It's written, right? Or if I equal to -1, return ARR.
yeah.
Return that. Right?
If ARR of I not equal to
Not.
okay, so ARR of something, I'm not sure what it is, will be equal to okay, will be equal to max of price of 1 plus cut rod of 7. Right. Now cut rod of 7 will again come and will call for this thing. Okay, and this thing let me see here return and cut rod of 7 basically cut rod of 7 will again call for I equal to 1 to 6 and will be calling cut rod of 6 and effectively everything will be calling cut rod of the basically cut rod of 1 will come at very last, right? And that will be the first thing to have. Now at that time it will be n will be passed as 1, isn't it? At that time n will be passed as 1, not I.
Correct.
For I equal to 1 till 1 I will be running my loop, right now? So cut rod of, and that time only one iteration will be there, so it will be going for ARR something, ARR of n or something, I don't know, max of price of 1 plus cut rod of 0, and cut rod of 0 will again call and will return 0, and that will be maximum of price of I, which is price of 1, which is 1, and it will be, that's it, 1. So here it should be ARR of I or n. Okay, right? It should be n actually.
Both are
No. Both are not same. Both are not same. Let's say I call cut rod of 2.
then it would be
Let me call cut rod of 2. Okay. Now cut rod of 2, let's say you have already stored 1 for cut rod of 1. Okay. Cut rod of 2 will call I equal to 1 till 2. So 2 iteration needs to be go for this. Now your cut rod of 1 again you will be calling, if I mean to say now if I take cut rod of I will be equal to max of price of I, which is price of 1 plus cut rod of n minus I, which is 1. Now is this right statement to make? Cut rod of 1 again, okay, you figured it out from the 1, so this is price of 1 is 1 plus 1 2. You will be again modifying cut rod of 1, which is not the right. Got the problem? So it should be cut rod of, this should be ARR of n, not cut rod of not ARR of I. Understood? Why? Because you will be again modifying it, which you don't want to have, right? So this simple, that's it. We will not be making any redundant calls, we'll be avoiding it, because cut rod of 1, cut rod of 2, anyway whenever they get executed and whenever they get completed they will be stored in my array, and I'm gonna fetch it for n greater than the previous n calls. Okay, for cut rod of 4 or 5 I can straight away use my cut rod of 3, cut rod of 2, cut rod of 1 results, whatever I have. Cool. So pretty simple. This was an easier thing to make it out from the recursive statement, because simply we just have to replace the ARR of n. But have we understood the logic, the funda behind it? That is important. Huh? Everyone is clear about this? Cool. Let's come to the complexity. Okay, can you tell me what is the complexity for previous call, recursive call?
n square.
Previous call. N square, huh? Okay, one combination. The recursive function that I have written in this way.
Not this one.
Not, well, I'll come to this later, but before this.
N to n.
N raised to power n is one option. Okay. So effectively, if you see, for 8 as well, you are going for 7, 6, 5, 4, 3, 2, 1. For 7 as well, you are going for 6, 5, 4, 3, 2, 1. For 6 as well, you are going to it. So it is exponential of n. It is
n into n minus 1 by 2.
that n into n minus 1 by 2. For every 8, for every n, you are going n times effectively, if you see.
N to the power n minus 1 times.
N minus 1 times in the worst case, which is n times, let's say. For 8, you are going. For 8, you are going n times. For 7, it's not like for 8 you are going n times. It's not like that. For 8,
n to the power
n
into n minus 1 by 2.
It's not n to the power n into n minus 1 by 2. No, man.
That's why.
No. So it's not like that. Otherwise, for 8, you are, that is itself a call. For 8, it's an exponential thing. It is like factorial, right?
Factorial.
5 factorial. Factorial is n raised to power n.
Then it has to be like 1 to the power 1 plus 2 to the power 2 plus 3 to the power 3, right?
Yeah, that is what happened. That is what I'm saying. 1 raised to power 1 plus 2 raised to, that is the formula for n raised to power n. So if you see 1 raised to power 1 plus 2 raised to power 2 plus 3 raised to power 3 plus 4 raised to power 4 is actually n raised to power n. This is the mathematical formula for this thing only. It's a series for exponential.
No, nth element would be n plus n. But
n raised to power n.
yes.
Yes.
But the sum is definitely greater than n to the plus n.
No. This will be this effectively will be n minus 1 raised to power n minus 1.
Correct.
Yes, which effectively will be n minus 2 raised to power n minus 2. Which further will be always be some constant into n raised to power n.
No.
Which will be n raised to power n. Right? That is what happening.
Yes.
4 raised to power 4 will be actually will equal to this complete thing. And so on and so on. That is what if you do 8 plus 7 plus 6 plus 5 plus 4 plus 3 2 plus, that is why how you do, right? So it will be n raised to power n only for this thing, and in this case let's try to identify. So we call this as exponential for this. N raised to power n is exponential time complexity. Now let's try to call for this. What it will be?
एक बार मिल गया तो मिल गया, बात के लिए नहीं.
Okay, so for 1, how many time will it execute?
1 time. 1 into 1.
One time, huh? 1 into 1, one time. For 2, how many time will it execute?
2 plus 1.
Okay, let's try to identify. For 2, first it will try to execute for
1.
cut rod of 2, 1 and cut rod of 1, है ना? Cut rod of 1 का result आ जाएगा. There will be 2 calls. It will not further disintegrate, right? It will be. Now for 3, it will be 3, 2, 1, and these will be call, but they will be direct results, right? For 4, it will be 3, 2, 1, and 4, right? So it is what?
Yes.
N square. This is like accessing the variables. These calls for 4 is what? Accessing the variables directly?
It's called some multiply into n, right?
No.
1 then.
I'll tell you. Let's see. I'll tell you how it is coming. Okay, first note it down this thing. Can I go to the next slide? Note it? Okay. Okay. Tell me this thing for int I equal to 0, I less than n, I plus plus, and for int j equal to 0, j less than or equal j less than I, j plus plus. Okay, print arr of j, let's say. Okay, and arr of j will be there. मान लो, ठीक है? मतलब कि n equal to 8 is there, and let's say you have 1 2 3 4 5 6. This is the output that we have. Okay, ठीक है? Now can you guys tell me the complexity for this? N square, right? Now let's try to relate what exactly is happening in our case. Now for, let's say if n had been 4, if n had been 4 over here, what it had been done? So let's say 3. Let's take a smaller case. For I equal to 0 to I less than 3. For j equal to 0 to j less than, first of all, I will be 0, j less than I, so it will execute for 1 time only, and so it will arr of j is executed 1 time, right? For I equal to 1, it will execute 2 times. For I equal to 2, it will execute 3 times, right? Now our program that I have written, what it will do for n equal to 4, it will first call for what it will call? It will call for cut rod of what? Cut rod of 3. Cut rod of 3 plus price of 1, right? This is an array access. This is also an array access, isn't it?
If it is fine.
If it must have been finalized when cut rod of 4 is called.
Correct. 3 would have been identified.
3 must have been identified that time, right? Plus what else called? Cut rod of 2 plus p of 2. Cut rod of 1 plus p of 3. Cut rod of 4. Basically, this is price of 4 plus cut rod of 0. Is this an array call? Is this a kind of 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 array call? This complete is a kind of array call. 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 Isn't it the same that we do? P4 is a array call. Price of 4.
That is already there.
No, n is 4, it will not have been determined.
No, this is not error of 4. This is price of 4.
The price of 4
Huh?
That is already there.
will only populate the error of 4 only when price of 4
No,
is
price of 4 is this my input array. Samya.
Correct, I got it.
This
I
is
think-
5, 8. This is initially given to you, man. This is what P is. This must have been there when the input is given to you. So this complete is an array call, isn't it? So isn't this the same that we are doing over here? Right? So for 4, it will execute 4 times. For 5, it will execute 5 times. For 6, it will execute 6 times. So how many times? 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8, which is what? Isn't it? So this is effectively the same thing that is happening here. Right? Got it, Guru? So the complexity, we have actually reduced our complexity from order of n raised to power n to order of n square by using memoization, plus order of n space, definitely space complexity. This is for space, but space is very cheap. If you are reducing down your problem statement from an exponential tail polynomial to polynomial, it is super awesome. Okay, yeah. So let's go to the next problem that we have. Noted? Can you go to the next problem? Okay.
Recording program.
Huh?
Recording program.
Recording on. Okay. Okay. This is the new problem that we have. Just read through the statement. I'll read. Given an infinite supply of coins of denominations, you have some coins with you, 20 rupees coin, 10 rupees coin, 5 rupees coin, 1 rupees coin, and you have infinite supply of them. Like in the previous case, you could have made infinite number of cuts. There is no constraint on the number of cuts that you can make. Okay, but the least coin that you have is 1 rupee. There you had 1 inches. Trying to can you guys visualize kind of the same thing? Find out the total number of ways to make change for a given amount of n. For example, let's say if the given amount is 20, if the given amount is 20, then I can make 20 in so many ways. Like I can include just 1 coin of 20. I can include 2 coins of 20. I can include 1 coin of 10 and 2 coin of 5. I can include 1 coin of 10 and 1 coin of 5 and 5 coins of 1. I can include 1 coin of 10 and 10 coins of 1. I can include 2 coins of 10. I can include one coin of 5 and 15 coins of 1. I can include 2 coins of 5 and 10 coins of 1. And there are so many combinations. All of them are mentioned over here. So we need to find
the previous one, right? There are some cut.
not 100% similar, 20% similar, not more than that. But here the number of ways you need to find out.
Not
The number of the combinations that you have.
There is no. You need to find the max there. Here there is no.
There is no max. The total number of combinations that you can find. Okay. Yeah. So this is what you have. Okay. For example, in this case, I guess total number of combination for making 20 with the denomination of 20, 10, 5, 1 will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 combinations. So you can make 20 in 10 different ways with coins of 20, 10, 5, 1. And if the amount given is 0, then the total number of ways to make any change is 1. You cannot include any coin. That is counted as one such way. Right? If I tell you, okay, make 0 from coins of 100, 20, 250 to 2, you'll say, okay, don't include any coin. This is one way. That's it. There is no other way. Okay? So I've given you the base condition as well. It's a kind of base condition if you see. So
What is the basic condition?
if the given amount is 0, then the total number of ways to make a change is 1. Don't include any coin from the given denomination set.
That is also
a way. That is a solution.
Okay.
Don't include any coin. That is a solution. Okay. Okay. So think through it. Apply. Try it to give a good effort, and we'll discuss it out.
So the number can be 100, 200.
N can be anything, and the input will be given to you. Denomination set, that also will be given to you.
So even this is dynamic.
Uh-huh.
20 or 10, 55, 1, that is also.
That is part of the input.
That is it's only this one.
That can also change.
No, that is the input, man.
Oh, correct. So input can change.
I can ask you to give me all the possible combination for making 50 using 5, 1, 10. I can give you any input, right?
They are too complicated. When you want earlier it was continuous, the input 1 to 8. So if you use this for loop from 1 to
Here as well, let's say these all are in the sorted order. Let me give the input. The denomination set that is given to you is in the sorted order. Assume this. You can take it as decreasing sorted order or increasing sorted order as per your convenience. Either 1, 5, 10, 20 or 20, 10, 5, 1. So any start point? Anything you thought of?
Question mark भी एक का 5 बार एक से हो.
Sorry, sir.
If you take, say start your denomination, right? Let's say
हाँ.
1 to x.
हाँ ठीक
You
है
take first one,
हाँ ठीक है it should be the highest one or the lowest one.
doesn't matter.
Okay.
So let's say the input is 5.
Okay.
The total number is 5. Your denomination is 1, 2, 3.
Okay.
So one can be taken 5 times.
This is first one
So
combination.
one will be loops against that with itself 5 times.
Okay.
Then has to take the next one, 2 and 3.
Okay. So 2 will be looped how many times?
2 will be looped 2 times.
And but the remaining is still 1. Then
5.
no, see, if you have to make 5, then you looped 2 times.
2 times.
So the sum is 4 now, but still 1 is remaining, right? How will you? Which one will you pick?
I mean, sir, I'm taking only about one only. One will be taken with itself 5 times. Now one has to take a combination of 1 and 2.
Okay. That's
Then
right.
1 and 3.
Okay.
Then 1, 2, and 3 all.
Okay. That is fair. Now, how will you solve each particular combination? That's the next question.
So I'll write an equation where it is satisfied to become 5 or not.
How? Yeah, you're totally going correct. Yeah. So let's say I understood what you're trying to say is, let's say the denomination given is 1, 2, 3, and the number that we have to make is 5. So first, let's try to make 5 with only 1.
Only one.
So there is just one way of doing that. That is
5 times.
5 times. But how did you determine that thing as well?
So I'll divide or something that should.
That is the core key. Just if you can figure it out that thing, then you will be able to solve for 1. If you have taken 1 and 2, then also what you have to do, you will be able to do that.
Yeah. So one equation I'm trying to figure out.
Yeah.
And do it.
That's a nice way to start. Definitely.
So I will take the module by 20.
Model
I'll
for
start with the largest. I'm actually starting with the largest.
that's fine. That's fine.
So I will take the modulus of 20 to the largest.
Okay.
Say 80, and my input is 80. Modulus of 20, I'll get 4 times
20.
20.
Okay.
Right. Now, after that, once that is done, each 20 I'll take modulus with the next smaller one.
Okay.
And that way iteratively I'll go.
So let's say the input is 50. You took modulus 2. You got the remainder as 10.
I'll get 20, 20, 10.
How will you get? Okay.
So,
Then
so if you divide by
Then-
20, you'll get 2. And divide by and remainder, it will be 10.
okay.
So 20, 20, 10. Now
Now
I have 20, 20, 10. Then further I'll modulus 20 with 10 each. So if the input is 20, 10, 5, 1. So first I'll do.
and what is n? N is 50. Suppose.
N is 50. Right. So n divide 20, then n modulus 20, 20, 20, 10. Right. Then I do n divide. So after that, 20 I do n divide 10 and n modulus 10. 20 divide 10 and 20 modulus 10. And that way till the end. So it will be like breaking it.
But
that's why
you haven't considered the case of just forming 50 with only 10, 5, 1.
Yeah, so that's what. So this is for 20. Then I do for 10. Then I do for 5. And then I do for 1.
Okay. Can you try write a recursive function for this? No, that is. I think that's a good start to make. Okay, let me give you a small hint. Let's say we are, let's say this 20 only. Okay, I will combine both of your ideas together. You guys have some part of the approach. I'll actually combine both of them. Okay, so you have 20. Okay, let's say you have to make 20 from 20 comma 10 comma 5 comma 1. Okay, right? This is what you have, right? Now in order to make 20, first of all, I should discard all the denominations which are greater than 20. Do I make any sense to include them in any of the solutions? No. Right? I mean, I will start with very common sense thing that we should judge in while solving any problem. For the very small thing we should observe, right? So first of all, sort them and discard any of the people who are greater than my n. It doesn't make any sense to include them at all, right? So in our case, let's say there are no as such. Okay, so all the denomination are either lesser or greater than or equal to the n. Okay, now when I'm making 20, this is my set, right? Right. Now either I can include this thing or either I cannot include this thing. There are only two options: either to include 20 in my solution set, either not to include 20 in my solution set. Right? Right. Now, if I include 20, this is, let me say, include. If I include 20, what will be the new sub problem that I'll have?
Is 20 plus
If 20 is included as one part of my solution,
then the other should be less than 20.
then that means to say I have to make 30. I have already included 20. So now, oh sorry, this 0, sorry. 0. I was considering with respect to 50. I'm sorry. Now I have to make 0 with 20, 10, 5, 1. What is the other possibility that we were talking of? Doesn't include, right? What is the sub problem now?
max.
No max.
Problem is
Create 20 with
10, 5.
Do you have solution for this? Do you have solution for this?
yeah,
You have the answer for this, right? 1, right? Right. Let's try to solve this thing. Let's try to solve this. This is still a call.
No, this one.
This one? This man, read this line.
Oh, 0.
You have the answer for this, right?
Why we make it 0 again?
Because you are including 20.
Okay.
So now your solution will be 20 and 20 coin is included to make 20. What is the new thing that you have to make out? 0.
Yeah.
0, right? So there is only one solution. So in order to make 20 with 20, 10, 5 by including 20, I can have only one solution, which is just take one point out 20. That's it. Got it or not? Now let's try to solve this thing. Okay. Now what is the solution? What is the possibilities that I have? Include 10.
10, 5 or 1.
Include 10. Right? So 10. Then now what is the new sub problem? I have to make 10 with.
No, why? Then 5 and 1 only, right?
No. That is 10 will be included 3 times. That is what I am not. That is I am not figuring out here thing. I have just in one level, in just this one pass, I am including 10 only one time. Now I can again include 10. That is a different story. But with this thing, I have included 10. So it's like every level I am picking one coin, just one coin. I'm not including 5 coins of 10 or 3 coins of 10. No.
It should be 10 plus that, right?
Sorry?
So why is this 20?
10 plus
No, just one by one.
Okay.
Tell me. Soumya?
10 by 1, right? That should be 10 should be separate, and then part to 10 by 1 should be separate. So 10.
That is what I'm saying. Now the new call is you have to make 10 because you have already included 10. You have already included 10. Now you have to make 10 because the remaining amount is 10 now. With the available denomination says 10, 5, 1. Hi.
No, I'm saying put 110 aside so that there is no confusion.
That is, so this is 10, okay? Let's say this is my solution set which is going on. So this is 20. So actually this is 20, 10. If you see this path, is it fine now? Is it fine now?
No,
Higher.
not included.
This is, oh sorry, 20 is not included in this path. I'm sorry. 10 only. Higher, Ravi. What was your doubt?
Wait.
Okay.
If 10 bacha hai, 20 minus 10. That's how it is.
Yes. This path is. Okay. Let's write down the path. Right. This path is 20. Okay.
20
now this is 20 not in. This is 20 included. 20 not included. 10 included. 10 not included. So this is 20 not included and 10 included. So that's why solution has 10. Is it fine now? Right. And the new call is creating 10 with 10, 5, 1. Is it fine now? And what is the other option I have? Creating 20 with
5, 1.
And what is here? What is here? Nothing. Because this path says do not include 20 and do not include 10 as well. Getting it or not? Now let's try to solve this one. Okay.
But here,
this here?
Yeah, 10 included, right? So that's what we write I versus 10. Right?
Yes.
Then why we are writing
10 everywhere?
We should write 5 and 1. Right? 10
No.
is included.
Just can you read this line?
Infinite subtraction.
I can include 10 as many number of times. There is no constraint on that thing.
Okay.
You can include 10 5 times. That is why this is one of the solution, man. Where it is? 20 coins of 1.
1 of 10 and plus 1 of 10.
There are so many. 5 of 1. Right?
1 of 10 plus 1 of 10 in between.
1 of 10 and 2 of 5. Yeah. Right? So this every solution will come. Right? Now let's try to solve this thing. Okay. What is this? Quickly tell me. What will be the two paths?
10, 5, 1.
This will be 10 and 5 and 1.
Yeah.
This is not included, you are saying. Just tell the included one.
This is included, right?
This should be included. Is it included? Man, then if it is included, then it should be 0. 0 and with 10, 5, 1. And here it will be 10, 10.
No, 0, 5, 1. Right?
Again, I have included 10. The denomination remains same here. Only not included, then it goes. What will be here?
10 not included, right? So 5,
1.
What is the new n?
The new one would be 10.
10. 5,
What is the solution set?
10. Sorry.
That's all. Right? Is it clear? This thing is clear? This thing is clear? Let us see. Okay? Let us see a recursive tree in a better fashion. Okay, look out from the 50 example. Okay, n equal to 50 and the denominations are 20, 10, 5, 1, guys. First is, this is another type of solution that I'm telling you. The first type of solution also I have told you. This is another kind of solution. So this thing is yours one. You will find a modulus basically, and basically for that time the loop will execute. 0. If I have to include 50, if I have to make 50 with 20, 10, 5, 1, then I have two options: either to include 20 or either not to include 20. If I include 20, then actually there are 3 possible combinations by either including 1 coin of 20, 2 coin of 20. So you get this. So this is actually not including part. Oh yaar. This is actually not including part. This is actually
What is not included?
20 is not included. That's why 0 coins of 20.
Okay.
This is our not included. And then 1 coin of 20 and 2 coins of 20.
20 is done.
20 is done then. 20 is done then. Right? Here, Now 10 is there. I can have 5 levels to this, 5 children to this. So the number of children are actually I am getting by dividing the highest combination with my n. That will be my number of children to any particular node.
Only one thing that we should add here is that modulus जो भी आएगा that was.
So 50 divided by 20 plus 1 because not included path as well. That will be always be my n divided modulus, or sorry, n, it's not modulus, n divided by, it's the quotient, not the remainder. N divided by highest denomination plus 1 will be the number of children to any particular node. At any particular node you are given with n as well. At any particular node you are given with the highest denomination as well. Because this is for not included. N divided by highest denomination will give you
first
50.
50 right?
N equal to 50. The highest denomination is
20.
50 divided by 20. 2.
Okay.
Plus 1 for not included path as well.
So 0 coin, that is the 0 coin of 20.
Yes.
That is the point.
Yes. Take this example. Okay, take this example.
I got
Take this example. 50 divided by 10 is 5 plus 1 6. It is having 6 children.
okay.
So this is your actually for loop. And so on and so on. Right? Is this tree clear? This is the other way of visualization. Yeah.
So yeah, if you see that, right?
This one?
No, from top itself n equal to 50. So there are 3 combinations. So if you see the last combination is n10, then there's 2 coins. So n is the modulus actually. So
N is the number that I have to make.
n is the modulus.
No.
Okay, if you do 50,
Yes. N is the modulus.
n is the
So new n which comes is the modulus.
So there are 3 n combinations here: n50, n30, and n10.
Yeah.
And then you go for it.
Yeah. Hi Ravi, you were having some doubt?
And it's same thing, 30 and 10, right?
How this came, So basically 50 divided by 20, 50 divided by 20 raised to power I.
First situation.
20 into I. 20 into I, and I starts from 0.
So that not included will come.
Right? And I less than wherever this thing will come. Whatever this thing will give me. Whatever this thing will give me. That is how. I'll show you the program. Don't go for the implementation. Just now try to understand what is going on. Is it clear? This path is clear? I know this tree is more complex as compared to the one that I've created earlier, which was pretty easy, just 2 paths every time. Need not to worry about anything. Keep on dividing it. Okay, right? So I want you guys to write a quick program for the one that we have. First, try to write a recursive function. Not for this one. This is a bit complex. The other way of solving the same method, where you have only 2 boys. Take it, not take it. That's it. End of story. Take it, not take it. Any node will have at that time how many children? 2. So that's easier to identify. Here it is different. So try to write a recursive function for that, and then we'll write the program for that, and then we'll write the program for this kind of approaches.
You go to previous.
That must have been rubbed. I'll write it again. Don't worry. Tick. I'll write it again. Yeah. Okay. I'll quickly write it. Okay. 20 with 20, 10, 5, 1. This is included. So 20, and now 0 with 20, 10, 5, 1, and this is not included. So that means to say this is 20 with 10, 5, 1. Okay.
This is also not included. 0, empty only.
This is empty.
No.
This is included. This is I, this is Ni. Left path will always be included, right path will always be not included. Okay, this is the convention I'm trying to follow. Okay, included means to say 10 10 and 10 comma 5 comma 1, and here it will be 10, and here it will be not included, so 20 5 comma 1, and here it will be not included, and here it will be included, so 0 5 comma 1, and here it will be 10 comma 10, and here it will be not included, so that means to say 10 with 5 comma 1, and this thing will be 10. Okay, you want me to expand further? I'll expand this thing as well. Okay, just for one more thing. So 20 and 515, this is included, this is not included. So
both are included. After 20.
Sorry,
20.
this 20,
No, this.
this 20,
Yeah,
this 20.
10. Yeah.
Ah,
10 is included.
10 is included. That's why it's in the solution set. 10 is included 2 times. 10 is only included 1 time. 25 comma 1. What will come over here? Included. Included means to say 5 is included. So 15, 15 5 comma 1, and this is empty. So just 5. And here not included means to say 21, and a solution set will have nothing. Okay, I cannot expand more than that.
Last one.
This one, huh?
No, no,
This one,
no, no.
this one.
It's included one. 10 included, right?
10 is included 2 times. 10 again, I can include 10.
So that's what this would be
0.
10 5 1, right?
0. Now the new thing that I am into is 0. This is 10 already,
No,
and
0 is okay, but still that would be the set will be 10 5 1. The set
will be 10 5 1. Yeah, sorry. Yeah, right. Nice catch. This is 10 5 1. Fine. So write down a quick solution to this. So in a way, I think I actually gave a both solution of U as well and U as well, where you will be including first trying to include one. Basically, let's try to go in the reverse order. First, I try to include 20. If you see here, I have included 20 in this path.
Yes.
Then I have tried to include 20 and 10. And then further, this path says try to include 20, 10, and 5 and all that stuff. Right? So this is your solution. The other solution which I showed you was actually your solution, but in a more refined way. रिकर्सिव फंक्शन वो तो हो जाना चाहिए यार, अब तक अपने तो फाइट ही नहीं है उसमें.
So it really fast function that initially different list of
Denominations. So your what the function find number of ways something should take int n and ARR of denominations basically, and just you can make sure that
Pass one boolean included non.
that is your implementation, and that is your choice whether to do that or not. That is your choice, but I think that's not required. We can do it without that as well, but the array of denomination can be passed in the sorted fashion, decreasing sorted fashion. लिखा यार कुछ? Okay, I am going to the next slide. This tree will again be gone. Okay, I won't draw it again now. Okay, done, right? Noted, everyone? Noted, Guru? Okay, let's go with the recursive function. Okay, so our function should be number of ways. I am giving the name. It should take int n comma ARR of let's say denomination d. Okay, equal to 0 if n equal to 0, right? Otherwise is equal to start and end as well. Number of ways not included. That means to say n comma ARR start will be, or this thing start will be plus start plus 1 end comma plus number of ways included. So n minus ARR of start comma ARR start end. That's it. End of story.
N pass करने की जरूरत नहीं है ना, the size of the array.
ठीक है, मत करो.
N minus start.
Start समझ में लगा क्या है?
Sorted में.
Basically start will be initially 0, then basically which this I need to pick, right?
Which
At runtime. Which one? Either I'm talking about the 10th domination this time or 20th denomination this time, or
Then why is it minus?
why it should be n minus ARR of start. You have included 20, so now the new problem becomes 0 n minus ARR of start. Start is the index.
Okay.
So the whole call for this thing will be number of ways 20 comma ARR that you are having it, and that too in the sorted fashion, comma 0 comma some whatever the length of that ARR, let's say 20 10 5 comma 1, so 4 in our case. That's it. It will go like this. So simple, man. I mean, once we create that tree, then creating this thing is not a big deal at all, and converting this thing into program is the most easiest thing I think in this complete world if we are programmer, right? So writing a program for this is nothing. Whatever is written here, just copy paste exactly, almost. We have written the function definition, function declaration. We have written function definition as well. If n equal to 0, then this thing. Else return number of ways n comma error of start plus 1. That's it. Right? So this is what we have. Okay. Let's go. Written. This thing is written. Okay. Let's go next. Yeah. So same thing. Same thing. Whatever I have written. Int s, int m, and int n, whatever. Int m is the start, basically. Same thing.
Yeah.
Whatever I have written, the same thing. Clear? Clear? Guru, can I go next slide? Now this is the other one. Okay. Let's, before coming to that, let's now, if we see over here in this solution, or probably in this, the tree that we have just drawn, there are so many redundant calls, in fact, that we are making. For example, what we have, number of ways of creating 10 with 5 and 1 is being called for 20 subtree as well, and for 10 subtree as well.
Combination, different, but same.
Same, yeah. It's being called so many number of times.
You're
Redundant.
1 5 or 5 1.
Not 1 5 and 5. That is also one of the use case. Another is, let me, if I have 10 with me, creating 10 with 10 comma 5 comma 1 will come inside that. There will be a subtree of creating 1 with only 5 comma 1, and that will come, and there will be another. This call will be again be repeated when I will be calling, or when I will be creating 5 with just 1 comma 5. Right? So there will be so many redundant calls, which, for example, over here as well. If you see, if we see over here, so this creating this thing, what, n equal to 0 coins of 5, n equal to 50, not this, n equal to 50, n equal to 40. Yeah, not in this, but in the previous version, right? Where we are going to have so many number of redundant calls. So that we want to avoid, basically, by creating a new array where we can store them, process them whenever they are available, right? So this is what we have. Just go through the solution. We are creating the same function signature, but I am creating a new array of table. Let's call a table of n plus 1 and m. Okay, basically 0th row, I am basically what it is going to do is, so it is going, we are going to create a array of size n plus 1 rows. So that means to say 21 rows if n equal to 20. Why that will be there? I'll tell you, just a second. Let's say we are trying to create n equal to 5 with 1 comma 2 comma 3. Okay, so this will be my 0 1 2 3 4 5. Okay, this is what you have is including only 1 comma 2 1 comma 2 comma 3. Not basically, okay, this, okay, let me, this actually 0 will come down. 0, I'll change it. 0 1 2 3 4 and 5. Okay, or I can create the array again. Yeah, sorry, it's a bit messy. I can, let's
graph
something similar. 0 1 2 3 4 5. Okay, so this is my, what I have is 0 1 2 3 4 5, and this is what I have is, this is my sum, and this is my set. Set will be 1, only 1 comma 2 and 1 comma 2 comma 3. This will be my final solution. If I can populate my array, this is where my final solution will be. Basically, what this each entry represent the sum and the set. Basically, if this entry is, how can you create one with the denomination 1, 2? How can you create 3 with denomination 1, 2, 3 with this entry? This entry, how can you create 4 with only denominations as 1? How can you create 0 with only denomination 1, 2? Is it clear now? What each entry denotes over here? What will be here?
Important is there should be sending out some order.
Some order, that's important. Now what will be over here? 0? Can I fill these entries? How can I create 0? There is only one solution here. Isn't it? Now, right? How can I create 1 with only 1? How can I create 2 with only 1? There is only one solution, na? By including 1 coin of 1, by including 2 coin of 1, by including 3 coin of 1, by including 4 coin of 1, by including 5 coin of 1. So at least I have filled this row and column without any computation or processing, right? These are the obvious things. I should try to fill my table as much as possible initially only, without going into the loop. This thing is clear. If it had not been 1, then I would not have filled it. Okay. Okay. Now let's try to do. What is there? What is there? Okay, we have done this line. This line as well. This line is this line, guys. Okay. Now fill rest of the table entries in the bottom manner. Now for I equal to 1 and j equal to 0, it starts filling up from here. Okay. Now what you have to do? First of all, either you have to include it and either you don't have to include it. There are only two options, isn't it? Now this is what including of I. This is what this I here is what? My n. I here is represents my what?
N or sum.
Sum. As according to our previous convention, it was n with respect to a tree. Sum. Okay, let me write sum. And j represent what? Denominations. Right? If I have to include I, the new sub problem becomes what? I minus s of j, isn't it? Huh? If it is not 0, that means to say it is already populated in the table. If it is greater than or equal to 0, that means to say it must have been populated in the table. Then return the entry from the table.
Maybe. We are not seeing anywhere in the syntax.
Huh.
So everywhere is 0
Initially this is 0, this is 0, this is 0, this is 0.
So this is 1, right? And the second line.
Let's have 0. Why we made it 1? Because our denomination consisted of 1. If our denomination is not having 1,
No, the second line.
That is doing this thing. 0 of I. This line is 1.
This line or this one?
This line, man. This column, this is I is column. Row is always 0. This is my first row. 0th row, first column, second column, third column. That is what I did.
It is wrong.
Why? Why it is
1 is
wrong?
okay. 1 and 2 by 1. The sum may not equal to.
Man, how to create 0 with respect to 1 and 2? How to create 0 with respect to 1 and 2 and 3? And rest everything is 0 right now.
Okay.
Then I entered here and I start filling up the entries here. Now there are only two. I here represents what? Row. Row means to say this, and this is what my sum. Right now, either to include this guy in the solution or not. That either to include it or not. So if I include it, then my new problem become what? I minus s of j or not? I minus s of j, right? I minus s of j. I minus s of j, if I include it, then I need to check whether it is already being populated in the table or not. If it is populated in the table, that means to say its value will be greater than 0.
All denominations from 1 to 20 are there.
Yes, yes. That is what we are. No. It basically denotes we are trying to create a 1 to 20 sum with denomination 1 to 5. I am trying to create every sum,
Yeah, that's
right? So if it is there in the table, then return it. Otherwise, return 0. So here, what will come? Here it will be 0 only. Okay, right? And if j is greater than 1, if j is greater than 1, j is equal greater than or equal to j is equal to 1, then return table of I comma j minus 1. That means to say don't include it. If I don't include it, then I have to go for I of j minus 1, which means to say without including what is there. This is 1 comma 2, right? If here if I don't include 2, what is the previous entry? Isn't it this? So let's take this entry. Here, let's say I have to fill this entry. So there are two options: either to include it, or either to include 3 or not to include 3. The new entry that had just came over here is 3, right? So if I don't include 3, then what is the answer? Creating 3 with 1 and 2, which is this entry, or not, right? If I do, right, so this y will be table of I and j minus 1, I and j minus 1,
Right.
previous entry of not including, right? If j is equal to 1, then otherwise this. So here it will be what? So if here j is what? J is our greater than or equal to 1. So table of this thing. Sorry, this is my table, no? This is my table. This is my table, not this. These are the columns. These are just for our representations. This is just for our representation. Table is just this much. Table is just this much. Okay, right? And we are filling this one. Okay. Now, yeah, for I equal to 1, we started with this. Now let's try to fill this thing. X equal to I minus s of j greater than 0. I minus s of j what? What is j over here? J is equal to 0. So s of 0 is what? S of 0 is 1. S of 0 is 1. If I is also 1, is it equal to 0? Yes, it is equal to 0. 0 minus 0 equal to 0. Then
0 minus s of j is 1, right?
sorry, yeah, 1 minus 1. I is what? 1. S of j is what? 1. 1 minus 1 is 0. If it is equal to greater than or equal to 0, then you fill the I minus s of j and j.
ये समझ में नहीं, ये पहला कंडीशन.
This one, huh?
No.
This one, huh?
This one.
This is for including. We have to include it. Okay. What does this entry suggest? You include 1. You include 1. When you include 1, what will be the new sum that will be there? What will be the new sum which will be there? It will be I minus s of j.
Right.
That is what it is trying to find out. That is what it is trying to find out.
Okay.
I minus s of j will be the new sum. That if you include this thing, if you have included this thing, then whatever is the entry at x, you find out that thing. So table of I minus s of j. Let's try to populate this table. Probably that will give us a better idea. So 1 minus 1 is 0. So that means to say it should return table of 1 minus s of 0 and 0, which is 1. So table of 0 and table of s 0 0 is what? 1. So 1 minus 1 is what? 0. So table of what it is? No, sorry. This is what it is trying to take. Table of I minus s of j. Table of I minus s of j. This is wrong now.
ये टेबल के लिए तो दोनों ही लगेंगे ना.
table. So that's
I minus sub j so row
comma this. Yes, this is like this.
Two-dimensional.
Table of I minus s of j
and then the other.
and this
Not comma. Correct.
just j. Right?
No. Correct. That's correct.
That's correct. This is what he is trying to do.
Two-dimensional.
Yeah.
First dimension is
I minus s of j and other is j. Right? So if it is greater than or equal to 0, so here I minus s of j comes to be what? 0. So table of 0 comma 0 comma 0. So which is what? 1. So here it will be 1. Got it or not? Okay, let's try to do this again. X equal to, I'll write it again. X equal to, x came to be 1. X came to be I minus s of j. If it is greater than 0, then what you do is you make it to be table of I minus s of j, comma j. Otherwise, you put it to be 0. Okay, now I is what? My 1. J is what? 0. So 1,
Also 1.
J is 0. J starts from 0.
S of j is 1.
S of j is 1. So 1 minus 1 is greater than or equal to 0. So it comes inside. So now table of I minus s of j, which is what? 0. I minus s of j is 0, comma 0. What is 0, comma 0? 1. So x is 1.
I is 1.
I is 1, j is 0.
0.
S of j is 1.
1, 2, 3.
Okay. Now, what exactly does this mean? What is the number of solution? What is the number of solution for creating one if I include 1? Isn't it 1?
Number of solutions.
Number of solutions of creating 1 by including 1. Now we have to find y, which states number of ways of creating 1 without including 1. Okay. Now let's see this thing. It comes to be if j is greater than or equal to 1. No, it is not.
J is
0.
0.
Right? So it will return 0. Y will return 0, man. Right now? Right? So y is 0 and table of I comma j is what? X plus 1. It should be, because number of ways by including and number of plus number of ways by not including. So this entry comes to be 1. Let's try to populate this entry now. This will be interesting. Right? What it should be? It should be number of ways by including my already existing denomination is 1. So now number of ways to create 1 by including 1 comma 2 and number of ways to creating 1 by only using 1 or excluding 2. Clear or not? This entry should be this. This entry should be number of ways to create 1 using either 1 comma 2 plus number of ways to creating 1 by only 1.
No, by only 2.
By including, if you have excluded 2, then what do you mean by only 2? That's the difference. That's the one difference. When you say included, so that means to say whatever is the previous denominations are there that you have already figured out plus the new one for which you are doing it. Previous one was there. And when you say don't include, you say only previous denominations.
So don't include 1, include 2.
Man, this is error of 1 comma 2. Error of 1 comma 2. So new denomination here is 2. New denomination here is 2. So that means to say it will be, if I include 2 in the previous denomination, then I have to create 1 with 1 comma 2 plus number of ways to create 1 with just 1. Is it right? Right. Now, can you guys tell me what this will be? Have we already find out this thing?
I come again.
Number of ways to include
One.
with just only one, which is just this entry we just did. Which is what this is, this entry which we just did. That's why if j is greater than or equal to 1, it returns table of I comma j minus 1. Is it understandable why he has written this thing? Right. Now let's see included one. Now we have to include. Right. So this don't include part is done. Right. Now let's see this part. Now, what is my I now?
Is
1.
1.
What is my j now?
J is 2.
1.
No.
0, 1. This is second iteration. Right. Now let's try to find out. X equal to 1 minus s of 1. If it is greater than 0 or equal to 0, then do this thing. So 1 minus s of 1, which is 2. So 1 minus 2 equal to minus 1. It is lesser than 0. It is lesser than 0. Then return 0. So the x will be now 0. Y will be 1. Table of this entry will comes to be 1. And it makes sense as well. If you try to make 1 with 1 comma 2, how many number of solutions are there?
Not there.
Just there is one solution only, which is just include 1.
So yeah, second line is always setting something to 1 only.
This line?
This line.
No. It sets the previous entry.
But it will set only 1 or 0. This
No.
should not be either value.
No, it will be na x plus y will change.
So
If x is also 1, y is also 1, it will come to be 2.
say the input was 3.
Let's come here. So here,
वो इन दोनों को जोड़ देगा वो।
हाँ, जोड़ेगा अभी।
ये previous का आ जाएगा।
हाँ, अभी देखते हैं.
X plus y.
Let's try to figure it out. We are trying to fill this entry, huh? What does it signify? Tell me. What this entry is supposed to signify?
Number of ways you can.
पिछले का sum.
No. Now, what does this entry signify? The question is.
Number of ways that you can
Make one by
one from 1, 2, and 3 points.
Awesome. What is the previous set of denomination?
1 and 1, 2.
What is the newer set that for which we are querying out?
1, 2, 3.
1, 2, 3, and 3 is the new one which got just added. Awesome. What are the two options that I have?
Either 3 or not 3.
1 or 2.
Either we have
1 and 1 comma 2.
no. Either we have 1 comma 2 to create 1, or either we have 1 comma 2 comma 3 to create 1.
With 3 included, so 1, 2, 3. 3 not included, then 1, 2.
Yes, that is the right significance. Clear? Now let's say we are trying to create 1 with 1, 2, 3. X signifies that thing. Okay? Let's see what it happens. So x equal to what will be I, sir? I now is j.
J is 2.
Awesome. Okay. Now I minus s of j is what?
I minus s of j is 0.
0?
1.
1? Very good. Very bad, man. Your maths, you guys maths is also weak. 1 minus s of 2, which is 1 minus 3, which comes to be minus 2.
Means it is greater than 0.
So that means to say it should return 0, which is correct as well. If I include 3 in creating 1, it should return me 0.
It shouldn't be.
Right? So x is 0. Now let's say y. Say y. Y will be what? J is what? 2. It is greater than or equal to 1. Yes, it is. It will be the previous entry, which is 1. So here it will come to be 1. Let's populate this entry now. Let's populate this thing. Now I here is what? Quickly.
1.
I is 0.
1, right?
I will be 2, sir.
Equal 2.
Thank God.
So
J will be
0.
0. Tell me X quickly. Quickly, final answer. I don't want intermediate calculation. You also know, please. Final answer X.
Minus 1 is greater than 0. 0.
Okay, your answer is 0. Okay. Your answer? No, this is not acceptable. No.
Table of
Kind of blacked out of this one. Little previous I
Where you are blacked out?
kind of entire stuff.
Okay. अरे इतना टाइम सौम्य इतना तो कंप्यूटर भी नहीं लेगा भाई जितना तुमने 0 यार simple and you see logically as well can you create it no
it will be
it will be sorry your answer is 0
No.
wrong
it will be 2.
2 okay yours is also wrong Guru okay tell me one thing forget about this calculation how can you create 2 with just what is the significance of this with respect to x
1.
no you cannot change that.
Answer will be 1.
Answer will be 1.
idiots yeah
No,
No, you calculate that it will be 1.
it will be 1 for sure and if you see logically as well
वो सारे ही बना देंगे सर.
वो सारे 1 आएंगे मैंने पहले ही लिखे थे वो आएंगे 1 I know वो मुझे भी पता है if you see logically as well number of ways to create 2 by including 1 is what just 1 why you are guys are thinking so much and y will come to what
Y will come to 0.
awesome so this thing will be everything will be 1 okay sure na quickly x for this one x for this entry two final answer okay Soumya Guru you are telling me x plus y right Ravi it will be 2 guys x will be 1 y will be 1 and if you see as well how many number of ways of creating 2 with 1 comma 2 how many number of ways
One.
either by 1 1 and by 2 only is there any other combination okay creating 2 with 1 2 3
2.
y will comes to be 0 because it will be 2 minus 3 which is minus 1 which will be lesser than or equal to 1 so it will be 0 x will be 2 right okay so this thing creating 3 with 1 comma 2
1.
creating 3 with 1 comma 2 x comma y से निकालो यार ऐसे नहीं x comma y से निकालो
2. So first
what will be the x
X will be 2, Y will be 0.
x will be 2 y will be 0
Yeah.
sure
Yeah.
what is j for this thing
J is 3.
3.
j are you guys j is 3
J is 1.
1.
1 so y is supposed to come to be
1. Y will be 1.
y will be 1
X will be
2.
about this
2 कैसे आएगा वो?
y क्या आएगा पहले ये बताओ
नहीं
Y 1.
फॉर्मूले से आ गया लेकिन ये नहीं
अच्छा ये सिग्निफाई क्या कर रहा है सिग्निफाई
1.21 कर रहे हैं
3.
no 1 2 or it's not like
with this formula are we calculating 1 and 2 and 2 and 1 both
No, 1, 1, 1.
Just- 1 and 2 simple
so
1, 1, 1.
1 1 1 and 1 2
हाँ
2 1 नहीं है
It's not like in which order you pick the coins. Finally, my question is कि which are the number of coins you are picking. In which order is not this thing. यहाँ पे क्या आएगा? 3. ठीक है? x1 आएगा, y2 आएगा, ठीक है? यहाँ क्या आएगा? 4 को बनाने का जो भी आएगा, चलो देख लेना फाइनली. Okay, is it clear now? Complete thing, right? So this is what the actual, we can say, the good question of a dynamic programming.
Very difficult.
No, it's not.
How will you actually think of anyone?
Okay, so I'll tell you how you will think it. Okay, but let's conclude it first. Then we'll come to how we are actually gonna think about it. So first of all, we identified. Okay, we figured out. Okay, there are only two possibilities: either to include it, either to not include it, and we created kind of created a recursive tree where the tree goes on. Every node was having only 2 children, but there are n number of, I don't know, a number of levels. So it goes on like that. It's pretty easy. What is the time complexity for that thing?
N to the power.
Then
And
n square. How?
because we'll be excluding whatever is.
No, the previous solution, the
Tree one.
tree one.
It was n into n square.
N square.
We'll be excluding, say, 20. Of 20, we'll be excluding the rest of them. Only going through. It is n into n minus 1 by 2.
N to the power log n होगा नहीं. Every has a 2.
Okay. How many number of levels will be there?
We are talking about this one, that one, that tree.
Tree n must.
No, that one.
Okay. Okay. How many number of levels will be there?
As many numbers we are giving.
Node minus 1.
No, that will be n. The size, the denomination size. That many number of levels.
Denomination size, huh?
That's
For sure.
The 2 to the power n.
2 to the power n. Finally, how? How? Yes, it is right.
ये ट्री का है ना, there are 2 children. फिर उसके हर किसी के 2.
Right. So if you see, yeah, I have to clear the tree. Okay, I'm going back to this. This will be rubbed. Okay, everything is okay.
About this tree, this one that you draw there.
Yeah.
I'm thinking about the one.
Everyone has
No. So every node is having 2, and you will actually be creating 20,
But
10
you asked levels, right? Not the
total number of basically total complexity.
You asked levels.
Number of levels will be what? So total complexity will be number of levels and number of nodes into number of nodes at each level. Right? So number of levels will be exponential. Number of levels will be exponential. Right? So 2 raised to power n. Right? And let's come to this solution. How much time will it take?
n square.
N square. Effectively, we are just iterating, right? And but there it was 2 raised to power m actually, if you see, where m is the denomination's size. Here n is the sum that I had to make. But definitely 2 raised to power m will always be very, very higher as compared to n. That's exponential, right? Okay, so now coming to the conclusion that first we saw, okay, how to create that recursive tree. We wrote a recursive function as well. We wrote a quick program as well. We saw another implementation as well where basically every level was having I think modulus n modulus the highest denomination nodes, right, plus 1 as well. So that is also we saw. Then we came to this solution where we are actually creating a new table and identifying the significance of each entry in the table. We are trying to find whether if to include it and to exclude it. If we have to exclude it, then it will just be the previous block that we have just processed it. If to include it, then we already have the formula for this, something related to that. So effectively, the last entry, the nth entry, will be the one where my actual solution will lie. Right now, the question is how to identify that. How to strike how to get a kick that something like this will be happening. So my advice is, in most of the dynamic programming question, most of the, not every, it's not a generic statement to make, but most of the dynamic programming question, try to create a 2D array. I mean, it's a kind of just a, it's not a foolproof, it's not a theory I'm saying you, it's just by experience I'm saying you, okay? So don't take it as a, a line on the stone. Yeah, so try to create a 2D array, okay? Now, whenever you create a 2D array, it's where before populating the 2D array, before actually working on the algorithm, when try to find the significance of each entry in the 2D array. What the entry, for what purpose I'm trying to create the 2D array? For what purpose? Each entry should notify or should tell me what? That is what you have to ask yourself and have to answer yourself. This is the most important step. Most important. If you have done this, for example here, if you see this thing, if I can ask myself, okay, what does this entry should denote me? This entry should denote me that creating 4 by including 1, 2. Which further I know from my algorithmic purpose that if I have to create 4 by including 1, 2, then there are 2 solutions, whether to include 1, 2 or whether not to include 2. If I don't have to include 2, then this is what I already have got. Right? And if I have to include 2, then if by including 2, the remaining whichever I am getting, my after subtracting is going greater than 0, is going lesser than 0, then I should not include it. So in that case, it should return me 0, sorry. Otherwise, it should return me this thing by including that thing and subtracting the previous entry. Right? So the main crux, the main funda, the main problem is how will I identify each entry in the table is going to denote me. So kind of quick hint is this only, that try to see, okay, if I can create a 2D array, okay, awesome. What each entry will represent me, awesome. Then try to populate that array. Basically, most of the times, and the next step before actually starting your for loop or any such of thing, always have pre-populating step. This you will definitely be having, because you must be knowing your your base conditions, and with the base conditions, your either first row, first column, last row, last column, the corners basically of the table must be populated, and with the help of them you are going to proceed further. Right? So that is what, and rest is experience, rest is practice, rest is your thinking. Right? Okay, but don't worry, we'll do more questions. Don't get scared. Okay, cool, no problem. So we'll start with the next question after 2:35. It is. We'll start at 2, maybe after 5-6 minutes, right?